multiple decades old. Because I'm over 60 now, I'm allowed to do that. So, all right, so normal to a curve. So we talked yesterday about finding the line tangent to a curve. So normal to a curve is the line perpendicular to the tangent line. So going back to as we did yesterday, if you look at a circle, you don't need to draw this if you don't want. The tangent line at a point is like that, right? So that's your tangent line. Your normal line is like this. It is, and I missed it slightly, but it's perpendicular to the tangent line at the point where it touches the circle.
That was on our homework.
Oh, was there a normal on your homework?
Yeah, it was like a C part of.
They had a lot.
A lot of them?
No, they had like a lot of questions. Because they had an A and B.
Oh, gotcha.
So it was like double the questions.
There was a couple normal things. I was like, what? Like, now I understand.
So normal is just perpendicular to the tangent line. So let's write an equation for the line normal to the curve, blah, 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 at x equals 1, and then we'll look at what the graph looks like. So first, we need a point, right? We always need a point, we always need the slope. So the point will be y is equal to f at 1, which is 1 minus 3 plus 4 is 2. So my point has coordinates 1, 2. So f prime of x, we haven't talked about that yet, sorry. I'm thinking about my BC class. When you guys are far apart a little bit, it hurts my brain. So the slope of the tangent line at x equals 1 is going to be equal to the limit as h goes to 0 of f of 1 plus h minus f at 1 all over h. And you can say 1 plus h minus 1 if you want to, again, to kind of remind you that this is the slope. So that's going to be the limit as h goes to 0 of, I'm going to have 1 plus h quantity squared minus 3 times 1 plus h plus 4 minus, I've already figured out what f of 1 is, so just minus 2 all over h. So expanding in the numerator, we'll have the limit as h goes to 0 of, that's going to be 1 plus 2h plus h squared minus 3 minus 3h plus 2 all over h. This is where something wonderful happens, because notice that the constants in the numerator, 1, -3, and 2, all add up to 0. That's what we hope happens. So it'll be the limit as h goes to 0 of, if I group the other like terms that are left, I've got an h squared and a 2h minus 3h, that's minus h all over h. So then, if I divide through by the h, I've got the limit as h goes to 0 of h minus 1. And what is that as h gets close to 0? -1. So that's the slope of the tangent. So the slope of the normal since it's perpendicular, what slope should it have? Pardon?
1.
1, yeah. It's the opposite sign and it's the reciprocal, but 1 is its own reciprocal. So we've got the slope, we've got a point. So that's going to be y is equal to 2 plus 1 times x minus 1. So 2 plus x minus 1. So y equals x plus 1. Again, when we take a quiz or a test, if you want to just leave it in point slope form, you're absolutely welcome to. The only reason I change it to slope intercept is because that's how your book is going to give you the answers when you're looking up the odds. All right. So this expression, f of a plus h minus f of a all over h, is called the difference quotient of f at a. It's the average rate of change from f from the point a f of a to a plus h f of a plus h. Graphically, it's the slope of the secant line. We talked about this. All right, we just didn't talk about this being called the difference quotient. Now, if we take the limit as h goes to 0 of the difference quotient, that's the limiting value of the difference quotient as the horizontal distance between the 2 points goes to 0. So, right, we're going to be at a, we're going to be at a plus h. We've got this horizontal distance. This point's not moving. This point is getting closer and closer to a. It is the instantaneous rate of change of f at x equals a. It is the slope of the curve at x equals a. All those things are true. So we can call it the instantaneous rate of change. Graphically, it's the slope of the curve, or we can also call it the slope of the tangent. The tangent and the curve have the same slope at that point, because if you zoom in on that point enough, it looks like a line. All right, page 2. So let's find the limit as h goes to 0 of the difference quotient for the function f of t equals 3t squared minus 4 at t is equal to 2. Interpret the answer if f of t represents the position function of an object in feet at time t seconds. So, if we take the limit as h goes to 0 of, let's go ahead and do the t plus h. It's not a bad idea to write it out every time for a while until you're sure you have this memorized, because this is a really important idea. But for time's sake, I'm just going to go ahead and go, all right, 3 times 2 plus h squared minus 4 minus 3 times 2 squared minus 4. Got to be really careful with parentheses here. We need to set a parentheses around the 3 times 2 squared minus 4 because we're subtracting all of that, all over h. That's going to be the limit as h goes to 0 of 3 times 4 plus 4h plus h squared minus 4 minus, let's see, that's going to be 2 squared is 4 times 3 is 12 minus 4 is 8. All over h. So that'll be the limit as h goes to 0 of 12 plus 12h plus 3h squared minus 12 all over h. When you're doing polynomial functions, this is always going to happen. After you've simplified the numerator, the constants are all going to drop out. You're going to be able to factor out an h and cancel. When you get to other functions, you're going to have to do some of the things we did in the first unit to find the limit as h goes to 0. So this will be the limit as h goes to 0 of 12h plus 3h squared all over h. I can divide by h because we're looking at the limit as h goes to 0, not what happens at 0, so I'm not worried about dividing by 0, which is a mathematical no-no. This would be 12 plus 3h. As h goes to 0, that's 12. So now it says, interpret this answer. Well, 12 is the instantaneous rate of change in the position function. F of t at t is equal to 2. And notice it tells us that it's time in t seconds, so let's go ahead and call it 2 seconds. Its units are, notice in the numerator, this is all having to do with f of t, right? The position function is the position of an object in feet. So that's feet on top, seconds on seconds on bottom, that's velocity. It is the velocity of the object at t is equal to 2 seconds. Now, we can do other rates of change. Not everything is velocity and acceleration and all that stuff that you do in physics. By the way, is anybody in here taking AP Physics? Okay, so you're doing a lot of this stuff right now, right? Acceleration, velocity, you're using the power rule a lot, which we'll learn in a little while. But not everything is that, right? Calculus is far from being restricted to just being physics, physics helper. It's a lot more than that. All right. Is that it? Excellent.